So hello guys. In this video series, I'm going to talk about several questions of the past Oxford physics exams, and the questions I select to talk about is not because they are extremely difficult. Um, it's sometimes because they are interesting, and sometimes because there are some subtle points um, that I feel is worth pay attention to. And also, um, there are some questions, some exam questions that their official answer is completely wrong. And I've been through the tutorials, so I know that the official solution is just wrong, and I will here uh, to basically show what is the correct answer. But um, those questions normally they're not difficult, so you can easily arrive at the answer yourself without watching this. But here is just as a check. If you get something different from the official solution and you just see a video posted here, you will know that okay, the official solution is wrong. So the first, I also I'm going to say that this video series is not for educational purposes. I don't have the qualification to teach anything. It's just basically a sharing of thought. It's a it's kind of a way of communicating what I'm thinking about those questions. And it's not like I assume that I know more than you do. That's impossible. Okay. So the first question is um, question one of the 2016 B2 exam. Uh, this paper is just terrible. Um, it's not. This paper is not difficult when you do it for more than for the second time. Like when you do it for the first time, you will find it's just a terrible paper. It's not because it is difficult. It's because like all the questions are really badly worded, and um and uh if your tutor talks about this paper, and he or she uses the official solution, then you'll find that official solution is just completely wrong. There are like at least four 100% sure wrong solutions written in the official solution, and that's just terrible. Okay. Um, so so one of them is in question one. Question one consists of a lot of I mean, all the questions in this paper consist of a lot of subsections and sub questions, and they are irrelevant to each other. So this specific part of this specific part that I'm going to talk about in this video um, is part of question one, where it says, so give the physical meaning of this expression. So d dot b is 0, and d and b are just two full vectors. Uh, yeah, this is a special relativity exam, by the way, if you're not from Oxford. Okay, so this full vector d is just d naught, and the three vector d. Okay, maybe that's just too big. For beauty purposes, I'll redo it. Okay, so yeah, so that's the four vector d, and the four vector b is just this b naught b. Okay. Uh, um, so in um in Oxford physics, we use the metric eta equals to this minus 1 1 1 1. So that's in special relativity, and relativistic classical electrodynamics. If you go to quantum field theory, you will use a different metric, which is 1 minus 1 minus 1 minus 1. So just be careful with that. And so the question asks about the physical meaning of d dot b equal to 0, and that's just I mean, the only meaning of this expression is just minus b naught d naught plus b dot d is 0, right? And this can be rearranged to get b naught d naught equals to the absolute value of the 3 vector b times the absolute value of the 3 vector d cosine theta. So cosine theta is the angle between the 3 vector b and 3 vector d. Okay, and we know that if you take the absolute value of both sides, then you will find that the absolute value of cosine theta is equal to, so 0 must be less or equal to this, and this is equal to, so that's b naught d naught over the length of b times the length of d. Okay, and this must be less than or equal to 1. Now, so far is the thing is very easy to do. The reason I'm talking about this question is because the official answer says, okay, the physical meaning of this expression, okay, the physical meaning of this expression is when one 4 vector is time-like, the other vector is space-like, and vice versa. That's just wrong, right? So according to what they say, if D is time-like, B is space-like, and if B is time-like, D is space-like, and if D is space-like, B is time-like, and if B is space-like, D is time-like. The 4 sentences I just said cannot be all true. The only things are true is that if, okay, for example, if B is time-like, then B0 is greater than B in terms of magnitude, then D has to be space-like. That's true, right? If one is time-like, the other is space-like. That's true. But if one is space-like, the other can be also space-like, right? You can have both. You can have both B0 and D0 equal to 0, and this expression will still hold, right? And if B0 and D0 are both 0, then the vector has to be space-like. So the correct way of expressing that, the meaning of that d dot b equal to 0 expression, using just one sentence, is that D and B cannot be both time-like. So that's it, right? The correct statement is B and D cannot be both time-like. Because if they are both time-like, then this expression would be definitely greater than 1. Right, but if okay, if you don't read, like if your tutor just copy everything down from the official solution, it might be, they will say, okay, if one is time like the other is space like, and vice versa, and that's not the case, right? The correct way is to say in the final answer is B and D cannot be both time like, they can be both space like, um, and there are a lot of other things that are much more wrong than this, in this 2016 B2 paper, in the solution to this 2016 B2 paper, and I will talk about those in later videos. Yeah, and I mean this is this is quite easy, but this mistake has happened multiple times for those who make the exams. In 2017, in you can have a look at B2 2017. Still first question, which is a question quite similar to this one, and it asks something like, oh, I don't have the question paper by hand, but it asks something like, okay, if one is space like, the other is time like, and so yeah, it gives this expression and want us to show that if one is space like, the other is time like, but the correct thing to show is actually the other way around. If one is time like, the other is space like, and that order or direction does matter. So actually, the question 1 of 2017 paper is also has a fatal mistake, and that's, I don't know why that appears in an exam paper, but you should be careful when you see this. Just do what you just write down what you think is correct, because from my experience, exam papers can have mistakes, and it's quite normal.